Alright, so welcome back to a new video. And as we discussed in a previous video, we'll be walking through the step module, then interaction, loads, and meshing. So before starting with the step, first of all, I need to define my amplitude. So this will be actually what we're gonna do. We are going to fix this section, and we are going to be applying the load in y direction. So it will be a static analysis, and for that the load applied will be monotonic. So I can just say like monotonic load, just tabular, and now I can even just write it with my hand. Now can type things, or if you have loading history back there in Excel or something, you can always bring that here. Alright, so what I'm gonna do, I already have the monotonic loading for one of other models, so I can copy it from here, as you can see. So, oops, just choose these two and drag it all the way to down, press shift, and then you can copy it. I'll also upload those modeling videos, how it's done. It's very complicated thing for now, but I'll surely upload those later to my channel, so stay tuned for those as well. So I can just paste it here. Now I can see that the loading's the final time step which we need for our step module, and the maximum amplitude for my displacement is 110 millimeters. Just make sure if you are using meters in your analysis, like Newton millimeter stuff, so for that you need to define is as a meter as well, so you have to divide it by 1000. Sometimes it happens that you define it in millimeter and your entire dimensions, everything, the stress strain, or in meter and unit newtons, and that will be a big problem because you are applying 110 millimeter 110 meters displacement to your model. So that really something to take care about. So 55 is it. Now what I can do, I'm going to show you how I can just take a look up to this amplitude. So just go to plugin, tool, and not here, but coming to the load step, again plug, tool, amplitude plotter. So I only have this one amplitude plotter, so I can just simply plot. As you can see, oops, my bad, tool, amplitude plotter, and plot. So as you can now see how monotonic loading is increasing gradually with the passage of time. Okay, so that's how it is increasing. You can just close this and dismiss it. So if you can remember your, while defining the steps, create a new step. So it will be monotonic step, right? You can just first go with the static general, and the time is, I would like to have the non-linearity on my model, and the time is 55. Automatic stabilization, all these things, we can deal with those later on. If there is any problem with our convergence, we can always play with those things without affecting the results too much, because some of them may affect your results. So for now we'll just leave it like this, and the incrementation is important. So the maximum number of increment, just I would like to have a very big number, so that even this big number of increment is reached, my model will not be terminated. So initial step is 0.1. Sometime it might be even like you might have to change your initial point, because the Abaqus will tell you that your initial time step is way too higher. So yeah, even let me just change it from now 0.1, and then the maximum increment is 0.5, let's say. So the purpose of those things is that even if your model is running smooth, you don't want to start from 1, 0, 1 second, 2, and then directly jump to 55 with the increment of 10 seconds, because in that case you will not get any data. You need to have a lot of data to later on uh, to to plot. So yeah, that's why it is important to have your time increment as smaller as possible, not too much, but because it will take a lot of time, it is too much small. Although in this case it is really small, so it will obviously take time, a lot of time actually, depending on your computer. All right, so the step is now defined, and now we have to do, gonna define our field manager, and then applying the load interactions. All these things can be done. So what I'm gonna do is I am going to do, probably need to have some sets, because when I'm applying load here, I need to monitor the displacement and load at this point. And also I'll be interested in something here as well, probably the stress and the strain behavior here. All right, so let's just simply define those things first. I can edit, so it's already fine. So what do we have for the whole model? The field output I'm interested in for the whole model, and the stress, failure and fracture, probably tensile damages if there were any, or the energy dissipations, like I can also choose those. But again, if you choose too many things here, so that will be, I need definitely the MIC stresses and the plastic strain, logarithmic strains, so displacement, yep, forces and reactions. So I definitely need my reaction force. I don't need this. And contact, I don't need this contact because I do not have any contact surfaces. And can click this output for rebars as well, although we do not have any rebars here, but anyways, and dismiss it. So the history output, actually the history output, we can do that later once we meshed our model, because based on that we will have some small sets, like at which point I need to have my displacement monitored, I need to have my force monitored. So all these things can be dealt with later. And the next thing is, what I'm going to do is come to interaction. Oh, we skipped interaction. We should have first interaction and then come to load, but anyways, it doesn't really matters. All right, so now we do have one interaction here, which is this. Well, if you go back to previous videos, we model each and every part separately, so we need to assign interaction to our surfaces. So to do that, what I can do, I can even create partitions here and then just create those, or I can simply just choose this entire surface and this entire surface and this entire surface, and then I can also choose the inner surfaces of the weld to tie them together. Both of them are fine, but so let me see what option do we have. Let's first try the entire surfaces, because the problem with others, surfaces here, is that you need to have partitions, and sometimes those partition might be problematic, because if you define any partition relative to anything else, any other point, for example, if you create partition here by taking this point as a reference. If you move this section anywhere, so this entire partition will move. So a good way to do that is when you create partition back in your paths at is here, which might be sometime time consuming because you need to do all the calculation to exactly came with this point, this point, this point, and finally this point, and the same for these two, this point and this point. But even that is not very difficult, we can also do that as well. And you know what, let's do that as let's do. So what I can do now, I can point, so I can write note, write down those dimensions with me. So it's 117.5, right? And the second one is 162.5. All right, done. Let me see. Can come back to parts, the base plate here. All right, so now I can do is not this, yes, partitions. So not through point. Let me see, where is that? Use datum plane, uses extended face. Probably this one. Let me see. Select the face. I'm going. Okay. Oh, not this option. Sorry, my bad. Let me see. Partition cell. Probably the selected datum plane. Do I have to have a datum plane first? Okay. Let me see. Features. Yeah, I can even draw lines here, but again, I don't want to do that. Probably this is the option that we're looking for. Yeah, this is indeed the option. All right, so now we can create partition here. So again, I need to know the exact location of my point. So that's the thing, we don't know. So it's 280. I'm gonna do this randomly, not sure, but I need to do this exactly with dimensions. So let's see. Oops, not this one. Dimension from this point to this point, it's 117.5, and from this to this was 162.5. Let's hope those are accurate and done. So now what I can do, I can choose this point like point and normal, select a point, this point, normal direction should this, create a partition, it will create the partition throughout your thing. Select this cell, done, point and normal, this is the point, and there you go. Alright, so I might need to, oh no, feature regenerate probably or not, it's already regenerated. So to verify where those two are accurate, you can come back to the assembly As we can see, they are exactly at the location where we wanted them to be, right? Or in other words, I can even verify that. How can I verify that? I can verify that by taking the distance of what? Yeah, the distance of these 2 points, which mean the thickness of this, and the thickness of the, or the length of the angle of my plane. Okay, so let's just cross verify that. It's always better to cross verify things. So from here to here, the distance is 45. It should be exactly the same with the sum from this and this. So we don't exactly know whether this point belong to my well or this partition. So we can have it from here. Well, I can just quickly tool query distance from here to here. So it's 10, 10, 10, 20, 20, and then the lower part, anything is okay. So lower part should be this, which is exactly the same with this. So tool query distance. If it's 25, then we are good because we need to complete 45 in total. Yeah. So this is 25 and this weld is 10, that weld is 10. So it gives us 45, which is exactly the same. So now we are good. The next thing is we should have the lower plate. This plate, we need to have partition here as well. So just coming to the lower plate. No, that's the upper plate. Lower plate, this one here. We need to have partition here, which is at 10 millimeters. So again, using the same exact option, this and done. And I want this face to appear. Not draw it randomly, and then so this is 10 and done. So the only purpose for doing this first step particularly is to have a point at this location, which we can use here by point and normal and to create a partition. So that's the only purpose of this thing, and done. And oops, coming to the assembly. So now you can see that I have a partition here as well. It should be throughout this thing. What I'm going to do, I am going to have create something which is called a set, but I have two bolted things. Okay. Oh, nope, no, the well, where's the bug? Okay, yes. So I can create a set, which is my weld. Continue. So I can choose all of this and done. Let me tell you why I've created this set, because I cannot choose any surface here for my traction. So what I'm going to do, I'm going to hide this set. Okay, coming towards the assembly, I have 12 instances. So this is my weld. I can suppress it, and now I can have those things. So what I'm going to do, I need to have surface. So this is my weld master surface. Continue. So for that will be this thing. Press shift, see this, and this. That's the master surface for my valve, because my valve will be attached to this. Done. And now I can resume the valve, and I have to at least suppress my base plate and also the lower plate, so that I have the welded section only. So again, come to the come to the what surfaces, yes, again. So well, slave surface, sorry, slave, and continues. So yeah, oops, not this, this, press, oops, shift. Whenever something like this happen, I can't find model, so always click this, auto fit, it will bring back your model. So now don't forget to press the, yeah, something like this, go a little bit, and this, and done. So now I can actually resume those things, resume it, all of them. So now I can define the interaction between these two. The other only interaction that we have is only between the bolts and the rest of the plates. Alright, so I was just checking something and I found out that because if you remember we have changed the angle here, we moved it to 0.5 mm in this direction, we moved the bolt, but this two holes is not moved in this direction, so that's why we also need to change these two holes as well to move it in this direction. So to do that we have to come back again to our base plate, and we can, what we can do here is to check the overall dimension is 280, and then I can check those dimensions, but one of them is 76, another one should be right to know about. Right, so this is 76, and this dimension is 128. Alright, so for some reason I had my headphone plugged off and I'm not sure whether my voice is recorded in the previous video or not, but anyway we have adjusted our thing here. The only thing left for now is the length of the bolt here, because if you remember we define our bolt based on these dimensions, but here we have 25 millimeter this, and then 6.4 this, and also 6.4 on the other side, so which is additional. We do not have the angle at this location, so we might need to extend or define a new bolt for these two directions. We cannot use the same bolts here. So what we're gonna do is we can find those bolts, or we can completely delete them from here and also delete it from here. And what I'm gonna do, I'm going to come to my bolt, and let me see, let me just check again the total distance that I need to assign to the interior parts of my bolt. So it should be 38.05. and why is that? Because we have this distance which is 25, and we have this distance which is 6.4. so we have 25 and then 6.4 and then 6.4. so that's the total
internal length of the bolt that I need to use. I can even cross verify that. So it's 25 plus 6.4, again 6.4, so it's 37.8. So it's 37.8, but apparently it appears that the distance between these 2 points is not 37.8, it's 38.05. So that's why it's extremely important to cross verify everything. So now let me check. So I can see that this is perfectly aligned with this. However, if you can see, there is a gap here for some reason, and I really don't know why is that. Anyways, I can always adjust this gap by choosing here, done, bring this point from here to here, and there you go. Okay, and done. So I might also need to change my bolts again, because I'm pretty sure they will be misaligned a little. But anyways, I'm gonna see. Let me quickly check one thing. Yep, seems to be misaligned. Yep. Alright, so in the assembly I can turn. What I can do is just, I'm gonna quickly adjust those. I'm gonna show you one and then pause probably video, and I'll do the rest and then come back. Okay, so what I can do, just for example, just move this to any other location, then done, and then again just choose any point suitable. Or the good thing is that you can always just do the query and identify your node. Let's see, for example, this node, done, oops, pointer node, this, and then press done. So this is my node. I can just copy this and translate my instant turn. So that node, where is it? It should be this one, should be this one here. So this, and exactly on top of that, and I can see now it's okay. Alright, so I'm gonna do the same for other and then resume the video probably. Alright, so I've done those adjustments. I need to define a new bolt for those two plates, upper plates, and apparently I need to have the dimensions of 37.8. So oops, let me see. Okay, nope, not here, done. Okay, I can probably, oops, edit feature, nope, nope, I can edit this, where did it go? Edit this feature. So instead of 31.4, let me see, the depth is 14.9. no, it can be, I'm gonna do the query till and from probably on this point all the way to this point. Give me a length, so it's, yes, 61.2. Sure. And so now I need to know what's, so this is 31.4, it should be 37.8. done, and apply, and okay. Just regenerate it, come back to the assembly, and I have the bolt for the upper part, mesh and pad, auto offset. There you go. I can rotate this bolt now, and let's say the starting point is this, and not sure will this, nope. Done. There we go. That's the starting point, probably this. Nope. That's why I need to move it first to perfectly align any 2 points, and then I can rotate it. Probably this point and this point. Yes. Nope. It's no. I want it to be in that direction, right? So it should be those 2 points. This point and this point. Yes, that's what I want. And now I can translate this. Probably I need to move it to, like, say this point to just have a clear vision. And what I can do now is I can choose, oops, I can choose, is that the point I'm looking for? Should be. So that's the starting point, and the end point I have is this one. And okay, tool query distance. I'm not sure whether I already knew this distance or not, but anyways, I should know. But anyways, let's just do it. Was it 76 if I'm not wrong? That's why it's always better to have fewer dimension and everything ready for you to take a look at. But anyways, I'm gonna quickly go to the upper plate and check the distance between these two dimensions. So it should be here to here, should be 76. Yes, I was correct. So now I can use this yep. So I need to choose the direction. It's Z, it's opposite, so this is now 76, and okay. So now my bolts are all okay. The next thing I'm gonna do is I will come to the interaction, create an interaction property. It should be just, let's say, general interaction, and contact. Then and the mechanical, I need to have the tangential behavior of 0.35, that's the fraction. So, and also like to have a normal behavior as a hard contact. So what does that mean? It means that every single thing that are connected to each other, this plate is connected to this plate here at this location, so that is having a fraction of 0.35, so that the plate might slide here as well if the force applied or whatever. And same is the situation for these two here, because when you apply the force, so this plate might slide against this plate. And the second thing is that I have a hard contact. So what does that mean is when two surfaces interact each other, they do not just press each other, or they do not penetrate into each other, so there will be hard contact. So there, like when you push one plate over the another plate, so this plate won't go inside the that plate or this any other plate. So that's why we have to define a hard contact as well. So now our interaction is, so the other thing we can do apart from this interaction that we have, we already specify the surfaces for that. We need to have this as a tie surface, but other than that we can assign our general contact to all of our other surfaces. So what we can do now is come to the interaction manager, create a new. So instead of our monotonic, I can come to our initial step, choose this and general interaction and continue. So all with self, but I'd like to exclude some sphere that I've already defined. So my weld, the master is the first, and the slave is this. And okay, so excluding this one, all should be tie with itself using this general contact. For now I don't need to assign other anything or play with those things like your surface property, contact formulation and contact properties. So I have already have the global property assignment here, and that's okay. And so anyone can edit now, see everything okay now. And the second interaction that I need to create is the surface to surface interaction. So this will be my weld interaction, right? So continue. It will ask me choose the master surface, so I already had it defined. This is my master surface. I can tick this to see whether all the master surfaces are selected, and then my slave surface, so those are the slave surfaces, and continue. So that's the oh no, I don't want that. I don't want that. I need to have the inside, not in the interaction manager, in the constraint manager. I need to create a tie surface, which is my weld, and continue. The master surface will be the weld. Continue. The slave surface should be the weld slave. Continue, and okay, dismiss it. Come here again to see whether, yeah, whenever is there a problem with your surface, when you click on this thing, tick edit, there will be an error message pop up. It will, if there is any problem. So now we are done with our interaction. So the next, loading and meshing, we can do that in next video because I really don't want to make this video too long. It's already 40 minutes, so let's see you in the next video. Okay.